All right, my friends, to get started on a problem like this where you think you could have two solutions, in this case you know because the directions say that, and to put your mind at ease when I test you over this, I will, in the problem, in the direction, say find two triangles, so you'll know that you're working with a two-solution case. Anyway, to get started, what I'd recommend you do is draw three pictures. So there's a master picture that looks like the construction that we did. Like that. And then the other two pictures would be those two triangles shifted out. So this is the triangle that's on the left there. So this is 20.5 degrees. This would be, let's see, this is A. This would be side length A, which is 12. And then we'll put angle B here. And then opposite angle B was side length B, which was 31. There we go. And then that would leave this to be C and this side length C. So this would be one of the triangles. And then the other triangle that has this side angle, has these lengths, would be the big outside one. So again, this is 20.5 degrees. This is 12. This is 31. And then this angle, I'm going to call it B prime because it's, probably a different measure than B over there. And then you could see angle C at the top here is, or angle C prime, that is, would be different than angle C was over there. And then this length for C would be different as well. So I'll just add little primes to indicate that they're different than the ones on the other side. So there you go. Okay, now to get started, at first, you don't really have to know for sure which triangle you're solving for. You could just start setting up, law of sines ratios. And so I can see with angle A and side length A, I have a complete ratio. So I'll get started with that. So sine of 20.5 degrees over 12. And then since C is completely unknown, but B is partially complete, I'll aim for B. So sine of B, and it could be B or B prime at this point. The math is going to actually kind of reveal that soon enough. So sine of B over 31. And then let's just go ahead and solve for B. So let's cross multiply and divide. And then to undo sine, we'll take arcsine on both sides. Make sure when you write arcsine, you always write it on the left of what you're taking the arcsine of to show that you know that it's a function. So arcsine is an action, more of a verb than a noun. All right, and then go ahead and punch this into your calculator. Make sure that you are in degrees mode. And then you should get approximately 64.783 degrees. There you go. Now I'm rounding it to the thousandths place because the idea is to have all your final answers accurate to the thousandths place. But on my calculator, I have all the extra 10,000ths, 100,000ths, decimal goodness. And I'm going to leave that on my calculator and use that for future calculations so I don't get round off errors on top of round off errors, if that makes sense. All right, well, now let's talk about, now that I've found this value for this angle, which triangle am I on the track to solve for? This triangle here on the left or the triangle on the right? And since the value I got is less than 90, I hope it makes sense that I'm actually on track to solve for this triangle over here. So I actually just found B prime, not B. So I'm just going to go back up and, in hindsight, change all my B's to B primes. So there you go. And now let's talk about how come, why aren't we solving for the triangle on the left, because honestly, that's the picture I was looking at when I set this whole thing up. But remember, arcsine, see how right here we took the arcsine. Arcsine has a range restriction. It cannot go past pi over 2 radians, aka 90 degrees. And so because of that, you will always be solving for the acute triangle first. In a situation like this. So we shall call the acute one triangle 1, and we shall call the obtuse one triangle 2. There we go. And we just found that this angle right there is approximately 64.783 degrees. So let's just finish triangle 1, and then we can transition to solving for triangle 2. So next, let's see, I say let's get angle C prime. So C prime would be 180 degrees, take off the 20.5 degrees, and then take off that value that you have there for B prime. So calculating that, it looks like we end up with, let's see, let me just do it. $94. Actually, I'll write it down here. 0.717 degrees. There we go. So up here. All right, so now we have angle C, and if we have angle C, we can solve for side length C, C prime, I should say. So let's do that. Law of sines, I'm going to set up, whoops, C prime, we know. I'm trying to solve for the length there, and then I'm going to set it equal to the original complete ratio for angle A. Okay, and then, whoops, all right, cross multiply and divide. I should say approximately 12 times sine 94.717 degrees over sine of 20.5 degrees. All right, figuring that out, looks like we're going to get C prime is approximately all right, 34.149. There we go, and meters. There we go. Okay, so I think we've solved this, the acute triangle over here now. So, because we know all the lengths and all the angle measures. Yep, we got it all. Okay, all right, now let's talk about, once you've figured all that out, how to transition over and solve triangle 2, okay? So it all has to do with that master picture that you drew in the first place. So notice this triangle over here on the right side is an isosceles triangle. So whatever the measure of this angle is, this angle would be the same. And so hopefully it makes sense that both of these angles right there, according to the work that we figured out from triangle 1, would be approximately 64.783 degrees. So then it's just a matter of a little bit of basic geometry over here. You could just take that number and take it off of 180. And we end up with 115.217 degrees for that angle over there. Yeah, okay. So now I'm just going to go ahead and label it over here. So measure of angle B right there. There we go. And now that we know two angles in this obtuse triangle, we could always just add the two measurements that we've got and take it away from 180, and we'll get the third one. So measure of angle C would be about 44.283 degrees. There we go. All right, and now all we'd have to solve for is side length C. So we'll just set up a little ratio and get it done. So sine of angle C divided by side length C would be, I guess I've got a rounded number there, so we'll say approximately equal to sine of A over A. There you go, cross multiply and divide. And we get 23.924 meters. There we go. And we've solved for both triangles. Okay, so just a quick overview. I really recommend the 3 pictures so that you can use that master picture to transition from your acute triangle to your obtuse. Hopefully it makes sense. You're always solving for the acute triangle first because of the range restriction on arcsine. And then, yeah, then you can just use that master picture and a little geometry to transition over. There you go. Okay, now as far as when are you going to get a 1 solution, 2 solution, or no solution case, I've got a little table here that kind of defines when you get which type. And a lot of people find this helpful. I personally don't, because truth is I'm never going to remember all of that. Now, you're going to get no solution if, if like the lengths of the triangle were not long enough to, close out the picture based on the angle measure that you got. And so the great thing is that even if you don't notice that before you get started with working the problem, your calculator would say error if you try to solve a no solution problem. And so when you go to take arcsine, stuff, your calculator will say error. And so, so what's nice is even if you don't know going in that you have a no solution problem, the math will reveal that to you as you go. So hopefully that makes sense. And then as far as when will you have a 1 solution or a 2 solution problem, this table is very helpful for that. But I will, on your quiz, make the directions say, find 2 triangles. And that's how you'll know that there's definitely 2 triangles to be found. When you do the problem set, you could always check your answers in the back. If you're not sure, whether you're dealing with a 1 solution or 2 solution case, and if they're 2 sets of solutions for a given problem, then you'd know that that was a 2 solution case. So then you just have to show the work to figure out both. So hopefully this makes sense. And if it doesn't, hopefully you're willing to ask me questions next time we meet in Zoom. Take care, everybody.